Hello, we're ready for video number 2. This is about our second rational number content standard, thinking about comparison. Just like if you remember back when we were starting with other numbers, we made those number cards. We played games where we were comparing one number to another number. This idea of comparison is a big part of number sense. And we want to revisit it. It's not just for kindergarten and first grade. We want to revisit it every time we tackle a new kind of number. So we're tackling a new kind of number with fractions. So we want to think about how these different fractions compare. And fractions, it's more complicated, right? So once we get the basic ideas of whole numbers, it becomes kind of very easy to compare them. Although some of that is because we've forgotten when it was difficult. Um, but usually, as we start to think about comparison, that means we've already thought about the numbers in context and we've thought about how to represent the numbers, right? Probably in a variety of ways. So when we're talking in this video, we're going to be thinking that the learners have already done some work trying to make sense of how to visualize and understand what that number means as a quantity. Okay, so mathematicians often break things down into cases, right? So if you want to think about comparing these complicated objects, these fractions, it makes sense to start with fractions that have something in common, right? So maybe they have a common denominator, right? So if we um, think about uh, comparing 2/5 and 3/5, which one's bigger? Well, if we have that basic understanding of fractions, it becomes obvious, right? We have 2 of a fifth, the same size, 3 of a fifth. Having 3 of them is more than having 2 of them. I don't have a cough, I promise. It's just having to talk. And that would work for any denominator that we put, right? If we are comparing twelfths, if we have fewer of them, the 12th pieces, that's less than if we have more of them, right? No matter how close the numbers are. If we have 15 twelfths and 16 twelfths, 15 twelfths is less than 16 twelfths. It's a little trickier to think about what if they have the common numerator. That's not a phrase maybe you even heard in thinking about fractions before. But what if we compare 1/3 to 1/4? Which one's bigger? How do you know? Well, we want to go back to that same fraction sense, but this time what we're changing is the size of the pieces. Which piece is bigger when we have 1/3 of the whole or 1/4 of the whole? Well, it must be when we break it into fewer number of pieces. So 1/3 is bigger than 1/4. Will that work even if we have more of the pieces? What if we have 3/5 and 3/7? Well, we have the same number of pieces, so we have more if the pieces are bigger. But notice how it's counterintuitive. If we just teach rules, like compare the 5 and the 7, which one's bigger, that doesn't help here. We want to be thinking about that 5 means we have a 5th. The 7 means we have a 7th. Which piece is bigger? We want to rely on understanding, not on giving the kids some rule that they're supposed to try to remember and then apply in different situations, and then have different rules that they have to remember for different situations. So we want to build the understanding that comes from those representations first. All right. So in these, we can probably make sense of those pretty directly. But we're going to need more tools because there's fractions that don't have both those things in common. Plus, this is just another way. In math, we love to have more than one way. So the second way is comparing them to numbers we're more familiar with, to have benchmark numbers. And so we can think about how numbers compare to those numbers that we know best. Like we could, if we have two numbers we're comparing, 1/4 and 1/6, and we just talked about a way to compare them because they have the same numerator. But we could also think about them in terms of which one's closer to 0, right? If we've started having some sense of magnitude, that 6th being a smaller piece, maybe we're visualizing it even closer to 0. So we can use kind of comparison to this to help with that. So what about if we had another case? These are numbers that are kind of close to a half, so I want to think about them there. 3/5 and 3/7. Well, one of them is bigger than a half, and one of them is smaller than a half. So that must mean that the 3/7 is smaller than the 3/5. The half serves as a kind of a division point. And we definitely know things smaller than a half are smaller than things bigger than a half if we get some practice sorting out how to compare numbers to a half, right? How do you know that 3/5 is bigger than a half? But what about if we had two that were on the same side of a half? Here's where we can see that comparing fractions can be pretty tricky. 3/5 and 4/7. So I'm going to share with you how I heard a kid think about it once. This was a kid that got really good at this benchmark thinking. I think it was a 5th grader. She said, 3/5, that's close to a half. 2.5 5ths would be a half. So it's a half of a 5th away. And the 4/7, same way, 3.5 7ths would be a half. So it's a half of a 7th away. Well, the half of a 5th is bigger than the half of a 7th. So I know that 3/5 is bigger than 4/7. Was she right? I don't know. That's some pretty fine reasoning. But we could also compare things thinking about them close to 1. So 4/5, that's getting pretty close to 1. We could think about how far away from 1 is it? Well, it's 1/5 away from 1. So if I wanted to compare it to 8/9, which one's bigger? Well, it must be 8/9 because that's only a 9th away from 1. But how do these two compare? Is that 1/5 away from 1 bigger or smaller than the 2/9 away from 1? Huh. Even if we're good at benchmark reasoning, there will be cases that we can't settle. So we need maybe more ways to think about it. So we have a third way where we use kind of this powerful idea that there's more than one way to write a fraction, right? So if we were comparing um, 2/3 and 3/4, well, we have a couple ways to think about that. We could be thinking about how far away from a half, how close to 1. We could be um, having a visual in our head or have kind of a magnitude comparison. I think my gut would be to think about how far are we away from 1 with these two. But there's another way to think about it, of course. So remember when we had the plate of cookies? So what would a 1/3 of the plate of cookies be? So 1/3 of the plate of cookies is 4 cookies. So 2/3 is 8 out of the 12. And a fourth, if we divided the cookies into 4 parts, That's only 3 of them. But we have 3 of those. So that means 3/4 is the same as 9 out of 12. Well, 9 out of 12 is more than the 8 out of 12. Back to the very simplest, easiest way to compare, right? The 12ths are the same size pieces, so if I have more of those pieces, it has to be more. That's pretty nice. But it can be tough coming up with what's the situation where we could think about both fractions, right? Why did 12 work for these two fractions? So there's a different picture that sometimes is close to the discrete, but it's really thinking about it more like the array. So for this one, I want to compare 2/5 and 1/4. So if I wanted to think about 2/5, I've got to break up this rectangle into 5 roughly equal parts, and then I've got 2 of them if I have 2/5. So we could make some divisions and think about 1/4. But now we're getting to the accuracy of my picture. I'm not so certain that my rectangles are the same size. And these fourths, I can tell they're not accurate. Like one of my fourths is smaller than the other one. So we want kind of a drawing method that's a little more robust. So instead of drawing the fourth that way, I'm going to draw the fourth in a completely different way. Excuse me just a second. Yes? Okay, we'll edit that out. By using both ways, we'll use both ways of drawing. We'll use both ways of drawing now in the same rectangle. So the 2/5, that's 8 of these pieces. Out of how many total? Well, we've got 5 rows of 4. This is where the array thinking comes into it. The 1/4, how many pieces is that going to be? Well, that's only 5 pieces out of the 20. So these two weren't even that close to compare. But it allows us to see pretty easily that the 2/5 is more than the 1/4. And in fact, I could even tell you how much more. If we think about comparison, it naturally leads to comparison story problems, right? If you had 2/5 of the bag of the chips and I had 1/4 of the bag of the chips, how much more did you have than me? You had 3/20ths more. So once we do get into operations, our work on comparison and representations is going to enable us to answer even pretty complicated problems. So that's fraction comparison, at least a start to thinking about it. And we've got some practice for you to do and ways to try to make sense. Remember, we're trying to make sense of these ideas. Okay, thanks very much.